Welcome to GoggleCam, the internet's first-person video of how to do lab.
Let's prepare the sample to use in phase mode. So we squeeze the pin here to release the plug and gently lift up the scanner head, and we can check that we have the right cartridge in the scanner head for tapping mode. When we want to look at phase, we need the tapping mode cartridge, and we can see that it's tapping mode because we can see there's these leads here, and there's a little tan chip inside that's a little piezoelectric crystal that will vibrate the tip. Now notice in the cartridge we have the chip carrier, and if we need to, we can remove it using this crowbar to lift up on this spring, remove the chip carrier. If your tip breaks, Brooker no longer makes pre-mounted chips, so you'll have to change the chip out of the chip carrier. And this tool, this jig, is used for that. It's very tricky. You need a lot of practice, so ask your instructor to help you with that. The chips come in these boxes glued down to this gel material, and so when it's a new tip, it's oriented with the probe pointing up this way. These are used tips. We put them in sideways to indicate that they've already been used. So again, it takes practice to move these etched pieces of silicon or silicon nitride and without breaking them, and since they cost about $50 each, ask your instructor for help. To mount the chip carrier, again, we gently lift on the spring here, and we want the chip, there's 3 big slots, are going to line up with the 3 rubidium crystals in the chip carrier, those little balls there. And I'm doing this left-handed. Of course, you would do this right-handed usually. Okay, so that's firmly in place, and I put a new tip on here earlier, so it should still work for our sample. And the chip carrier slides into the scanner head in this slot. Press it in until it snaps and locks into place. The sample we're going to look at today has urea crystals embedded in polydimethyl siloxane, and so the phase mode in tapping, the phase contrast in tapping mode, should help us see those urea crystals, which have different properties from the surrounding polymer matrix. So we slide the sample onto the sample holder, magnetically held in place there. The scanner head has the 3 points where it's going to rest on these 3 micromotors. We start with the larger channel in the rear, and then the smaller channel toward the front, and finally end with this single hole here to lock the scanner head into place. Okay, once it's resting on those 3 points, it's very stable, like a 3-legged table, and we can go ahead and plug the scanner head in. So do that gently. Bring the optical boom over so we can see the probe and the sample, and you can see the probe is close to the sample surface, and it's right on the edge of the sample, so we can move the probe with respect to the sample with these knobs here. This moves it right and left, this moves it front and back. So we want to try to go back so that we're over the sample. If need be, we can remove the scanner head and readjust the sample position to make sure that the probe is over the sample. Looks like we moved that. Now we need to move the optical boom camera so it's looking at where the probe is, and to do that we use these 2 knobs here, And so if we move these knobs, we should see the light from the camera moving. Okay, so now we can focus on the probe and check the alignment. These are the focus knobs for the optical camera, and you don't want to, this is that larger one's the coarse, the smaller one's the fine. Move those gently, they are breakable. Another video shows you how to align probe. When you're done with the alignment procedure, it should look something like this, where the spot is being reflected off the end of the cantilever. Now, is the probe anywhere near the sample surface that we want to scan? We can motor down. Click this button here to get to the motor control. We can motor down the the scanner head so that it gets closer to the sample surface. And I do that clickwise. You can see it's moving closer. And we don't want to get too close yet, because we don't want to accidentally crash into the sample surface. So let's look at what the sample surface looks like. Okay, so that's our sample surface.